right? They're walking away. So if I'm walking 4 miles an hour one way, just say we're back to back. I go 4 feet per second one way, someone else goes 5 feet per second the other way, then it's really like one person walking 9 feet per second, right? So it seems like the only way we're going to get 9 is if we make them both positive, right? Right now, because this is something you've got to deal with when you go through these problems. You might get stuck on something like, is it positive or negative? I don't know. I'm going to put a highlight here, and next to it I'm going to put plus, minus, question mark, okay? Because I think that's a valid question. And maybe we haven't completely resolved it yet. Now I'd like to see if we can come up with the thing we want. So what do we want? That green, right? How fast that green's changing? We haven't labeled the green yet. So let's call it something. Z? So I want dz dt. Don't I? How fast is the z changing with respect to time? At what particular instant am I interested in that? When what? Okay, in terms of our picture though, when is it? Yes? Look at our instant in time. Look at our instant in time. Don't we know what x and y are at the instant in time? Don't we? So we want to know how fast z is changing at exactly the instant that x is, what? 4,800 and y is 4,500. And now I think we've got everything we need here. What we're given, what we want. We still have a little question mark about the plus or minus on that dy dt. We know exactly the moment in time where we're going to fix everything. So all we need now is the equation, right? Something that relates what together? We actually want to relate x, y, and z together, right? Those three variables, x, y, and z. Scroll down a little bit. Equation with x, y, and z in it. So going back up to our picture really doesn't lend itself to a nice, formula unless we kind of see it a different way. And that's what some of your classmates were referring to, right? So I'm going to kind of redraw this down here so I can do it side by side. We have our distance across. We had our 500 going this way. We had our x. We had our y. Here's our 500. So the idea, and let's just see if we all agree with this. The 500 we have there on the bottom is the same as putting a 500 this way. Like that. That's right. Do you all agree with that? And then the x that we have here, if we put it right here, we would have x there that goes from here to here. The y goes from here to here. Yeah? And then the z, of course, is still here. And we have a new triangle that looks like this. It's 500 here, z here, and this side is x plus y. And it's a right triangle. Now, the z is growing, right? As they walk away from each other, the z is growing. So are you thinking now that we should use that positive or negative on that? Remember we weren't sure? It's looking positive, doesn't it? Look positive to you? Okay. We'll still get back to that later. Everyone happy with that picture? Okay, let's try it. So now I need to come up with an equation. So what equation relates those variables together? Pythagorean identity, right? A squared plus b squared equals c squared. And just be careful, it's like A, this is like B, the hypotenuse is C. So I have 500 squared, which is what? 250,000 equals plus what? X plus y squared equals z squared. There's your equation. And now it's differentiation time. You cannot fix anything, right? You can't fix your x, can't fix your y, can't fix your z. They're all changing until after we differentiate. Oh, good. What's the derivative of 250,000? 0. Good. Okay. X plus y squared is going to require what? Chain rule. Junk squared, right? What's the derivative of junk squared? 2 times junk to the first power, right? I don't need the 1 there, but I put it. Times the derivative of what's inside. What's the derivative of what's inside there? Careful. Careful. dx dt plus dy dt. So again, because we're differentiating with respect to time, the derivative of x isn't 1, and derivative of y isn't y prime, it's dx dt and dy dt. But it was just a sum, so we didn't have to worry about product rule or anything there. Are we done on the left side? Yes? I'm going to get that 1 out of there. It's just bothering me. Equals now. Derivative of z squared. 2z dz dt. What if you forgot dz dt there? What if you accidentally forgot to do that? You wouldn't have what you're trying to solve for, right? You'd be like, okay, now I should be able to go find dz dt, and you're like, where the hell's dz dt? Right? But you have it. It's there. That's what I want. Do I know, see, now I can fix everything. Do I know what x is at the moment in time? Yes, 4,800 or something like that. Do I know y at the moment in time? Do I know how fast the guy's moving, dx dt? Do I know dy dt? Do I know z? We never figured out what z was, did we? Can we figure out z? Sure. So a little scratch work here. To get z, here's what I've got to do. I've got to go back to this picture. Well, there's a couple ways you can do it. How about we go to this picture that was 500 z and x plus y. At the moment in time, isn't this 500, that's z, isn't this 4,800 plus 4,500? So 4,800 plus 4,500. Yeah, so this is 9,300. And now I know that 500 squared plus 9,300 squared equals z squared. So I just take the square root on both sides. Could you all do that computation to get z? Is it a nice number or no? Who? So z is equal to 9313.43. We'll just go 2 decimal places, that's fine. Is that okay? Anyone have a question on how we arrived at z? So now I can come back and check that off. We do have z, and dz dt is what we want. So I think I'm ready to plug everything in. Okay, coming back down here, we've got 2 times 4,800 plus 4,500 times, oh yeah, dx dt was what, 4? Plus dy dt was 5. Yeah. And then equals 2 times 9313.43 times dz dt. Any questions on that? All right, I'm going to just multiply that all out. Does anyone have it yet? Or the final answer? 8.9. Anyone else get 8.9? No? $8.98? 8.8? Yeah, 8.98. I'm getting the same thing. 8.98, 8.99, however you want. I'm going to go 8.987. How about that? Equals dz dt, which is measured in what? What is it? Feet per second. I've never done this problem, so let's see if we got it right. Which one is it? 17 on 2.7? Let's see if the books agrees with us, I should say. No, it says 8.99. Yeah, so we're good. Okay? What do y'all think? Oh, yeah, every single one of these problems is unique. I mean, some of them have similarities, but I always say, like, you kind of know where you are in Calculus 1. If you can do these problems and you feel comfortable with them, like, that's a really good sign. All right, so let's do one problem. When you finish this problem, you can go. Did y'all see the homework assignment? I had that earlier. Hold on. Let's talk about what we want to do next time. We were supposed to today do 3.1 and 3.2. But 3.1, 3.2 is actually a review from college algebra over exponential and logarithmic functions. So it's super quick, and there's not a whole lot to it. I'm not going to ask a lot. I'm not even going to ask for any homework out of 3.1 and 3.2. 3.3 has to do with derivatives of exponential and log functions, so you do need to look at that. And then 3.7 is very important. It's called L'Hopital's rule, and we'll be covering that. So even though it says to watch 4 videos, it's not, as far as time, it's not a whole lot of time. Those videos aren't as long as the ones that you watched before. The homework that's due for next time, 2.6 and 2.7, I sent that in an email when I told you all that other stuff. So just finish that homework. And I've left, really, I only asked you to do the first few problems out of 2.7 for homework. I'm probably going to add a few more to that, but kind of as we continue through the semester. Because these problems take a while, and I want you to continue to work on them. It's not going to be something we're just going to leave it behind forever. Probably every week I'll be giving you another problem out of here to look at. Okay? All right, so for today, for right now, Uh, no, that one's too mean for right now. I wanted to give you an even one, but okay, 20, where is it? I just had it. Sorry, I lost it. It was a rocket firing. Where did it go? Okay, we'll do 37A. 37A. Number 37, just part A. And then if you get that, check it in the back of the book, because it is, the answer is there. And then ask for me to see your work, and I'll come by, and you can go after you get it. Good luck.